Hello everyone, and welcome to the channel Chemistry Without Cramming, a bowl of chemistry knowledge. If you are on this channel for the first time, my name is Agnes and I'm here to convince you that chemistry does not have to be difficult. In previous videos, you could have learned how to solve problems around percentage, molar, and mole concentration of solutions. We solved problems in two ways. You have chosen the best method for you. Today we will do something different. In this video I will show you converting percentage concentration to molarity and vice versa without using formulas. Of course, I'm not suggesting to you that these formulas are incorrect. But firstly, solution based on formulas I have shown in previous videos. Secondly, in all school textbooks you see formulas and formulas every day. Thirdly, I checked personally. There are many videos on the internet which present the conversion of this concentration based on textbooks formulas. So why do I have to repeat it to you? So today we will do it differently. Today will be without formulas. To cope with the conversion of this concentration, we will leave just one tiny formula for ourselves, a cherry on top. But you don't have to memorize this formula, and I will explain everything to you in a moment. Today, I will also present to you a guide to solving this type of problem. With such a guide, you will be able to cope with tests and exams more easily. I warmly invite you to listen to these lessons and leave comments. Let's start. If we are to convert concentration, let's remind ourselves what the value actually define. Percentage concentration, percent by mass of the solution, determines the number of grams of solute in 100 grams of solution. The molar concentration, molarity of the solution, determines the number of moles of the solute in 1 liter of solution. I would like to remind you that 1 liter is the same as 1000 cubic centimeters. Well, it's time to solve a problem on this topic. Problem number 1. The percentage concentration by mass of the potassium hydroxide solution is 10% and its density is 1.01 gram per cubic centimeter. Calculate the molar concentration, molarity of this solution. Let's start by writing down what we know and what we need to calculate in this problem. We know the percentage concentration by mass and density of the solution. We are looking for the molar concentration of the solution. We calculate the molar mass of our compounds. In this case, it is potassium hydroxide. From the periodic table, we read the atomic masses of potassium, oxygen, and hydrogen, write them as molar masses, and of course add these masses together. We get a value of 56 gram per mole. Now we know that each mole of potassium hydroxide weighs 56 grams. I write down the molar mass of the potassium hydroxide data under the problem data for two reasons. First reason, I have limited space to present the next stages of solving the problem. Second reason, by writing it this way, we know clearly what information has been provided already and what still needs to be calculated. Now we need to calculate the mass of liter, or other words 1000 cubic centimeters of the solution. How to go from mass to volume? At the beginning of today's lesson, I mentioned that today we will use only one formula to convert concentration, which does not need to be memorized. I mentioned that this would be on our cherry on the top. Now, it's time for the cherry. Well, if a given problem requires you to convert mass into volume or vice versa, then you need to know the density of the given solution. Otherwise, we will not be able to convert it. If you have the density value in the problem, you also have its unit. In So in our case, gram per cubic centimeter. We know that gram is mass and cubic centimeter is volume. Without gramming the formula, we can write that D equals m per V. This is the formula resulting from the unit of density. This is our cherry on the cake. It will be the only one we will use when solving problems. Of course, in the problems, you don't need to calculate density, only mass or volume. In short, the one given on plate in the text of the problem, the formula, should be converted into mass or volume. This formula can be transformed, for example, using the popular triangle method in which we enter our mass, volume and density. Guys, if you like this lesson, please leave a thumbs up and share this video with your friends who struggle with learning to solve this type of problems and hate cramming formulas. Meanwhile, we return to our problem in which we have to convert the mass of the solution into its volume. In our problem, using density, we calculate the mass of 1 liter, so 1000 cubic centimeters of the solution. Now we know that the mass of the solution is equal to the product of the density and the volume of the solution. After substituting the data, we see that cubic centimeter is cancelled out and the result is in grams. Now we know that 1 liter of this solution weighs 1010 grams. Let's write this value under the data in the problem. Now we need to calculate the mass of the solute contained in a 1 liter of the solution. 100 grams of the solution contains 10 grams of potassium hydroxide because percentage concentration by mass is 10%. So 1010 grams of the solution contains X grams of potassium hydroxide. We calculate X by cross-multiplying this proportion. 100 grams times X equals 1010 grams times 10 grams. To solve for X, we need to divide both sides by 100 grams. So it follows that X equals 1010 grams times 10 grams over 100 grams. We see that grams and two zeros cancel out. So X equals 101 grams of solute. Now we know that in 1 liter of the solution is 101 grams of the solute. Let's write this value under the data in the problem. The next step is to convert the mass of solute, in our case potassium hydroxide, into moles. 1 mole of potassium hydroxide weighs 56 grams. So X moles of potassium hydroxide weighed 101 grams. We calculate X. X equals 1 mole times 101 grams divided by 56 grams. So X equals 1.8 moles of potassium hydroxide. Now we know that 1.8 moles of the solute are in 1 liter of solution, so we have the molar concentration, molarity of the solution. Answer: the molarity of the solution equals 1.8 moles per liter. Strategy to convert percentage to molar concentration. 1. Calculate the molar mass of the compound given in the problem. 2. Calculate the mass of 1 liter of the solution using Cherry formula. 3. Calculate the mass of the solute contained in 1 liter of the solution. 4. Convert the mass of solute contained in 1 liter, mass from step 3, into moles. Please write in a comment whether this method is easier for you or whether you prefer to solve problems based on traditional textbook formulas. Problem number 2. The density of a sodium chloride solution with a molar concentration of 0.5 mol per liter is 1.03 gram per cubic centimeter. Calculate the percentage concentration by mass of this solution. Let's start by writing down what we know and what we need to calculate in this problem. We know the molarity and density of the solution, and we are looking for the percentage concentration by mass of the solution. We calculate the molar mass of our compound. In this case, is sodium chloride. From the periodic table, we read the atomic masses of sodium and chlorine, write them as molar masses, and of course add these masses together. We get a value of 58.5 gram per mole. Now we know that each mole of sodium chloride weighs 58.5 grams. I write down the molar mass of the sodium chloride under the problem data. Now we calculate the mass of solute in 1 liter of the solution. 1 mole of sodium chloride weighs 58.5 grams. Our solution is 0.5 molar, which means that there are 0.5 moles of solute in each liter of solution. So 0.5 mole of sodium chloride weighs x grams. So x equals 29.25 grams of sodium chloride. I write down this mass under the problem data. Point 3. Calculate mass of 1 liter of the solution. How to calculate? How to convert volume to mass? We need to use our cherry on top. Mass equals D times V. That is, the mass of the solution is equal to the density of the solution multiplied by its volume, so by 1000 cubic centimeters. Now we see that 1 liter of our solution weighs 1030 grams. Let's say this value under the problem data. 4. We calculate the mass of the solute in 100 grams of solution, so we calculate percentage concentration by mass of the solution. 1030 grams of solution contains 29.25 grams of sodium chloride. So 100 grams of solution contains x grams of sodium chloride. So x equals 2.84 grams of sodium chloride. Answer: percentage concentration by mass of the solution equals 2.84%. Strategy for converting molar concentration molarity to percentage. 1. Calculate the molar mass of the compounds given in the problem. 2. Calculate the mass of the solute in 1 liter of solution using the molarity given in the task. 3. Calculate the mass of 1 liter of a solution using the Cherry formula. 4. Calculate the mass of solute contained in 100 grams of solution. The calculated value is the percentage concentration by mass of the solution. Guys, that's all for today. Thank you very much for your attention. If you like this video, please leave a thumbs up and subscribe to my channel to follow the next subjects. I also invite you to leave comments. Is the method without formulas easier for you to solve this type of problems? Thank you very much for your attention and see you in the next video.